Hi, welcome back to Mini Rust in Rust. This is video 41. We're writing a little programming language that looks a bit like Rust in Rust. It's going to be interpreted, at least to begin with, not compiled, so it will be a bit different from Rust, but so far, we haven't varied from how Rust works in terms of any syntax. And we haven't really got far enough with how it actually executes to vary from Rust in terms of meaning. Anyway, so what we have been skirting around is trying to make our type checking actually check the types of things properly. We did actually do something last time. We managed to get our while loops to complain if we gave them something that wasn't a Boolean, true or false value. But what we haven't done, that's okay if we give it like a 3 or something, but if we give it a variable, we're not checking anything to do with variables. So I'm not sure how far we're going to get in this video, but we're going to start down the process of remembering what type a thing had when we created a variable and then checking it later. And hopefully at some point that will expand into not just remembering what type it had when we created it, but any other things we know about it that mean it must be of a certain type. Even perhaps, for example, that we used it as the expression in a while loop. That means that that we kind of can infer things about its type. Anyway, I'm getting off track because it gets really complicated. So first thing to do is try and come up with an example that should fail and figure out how it should fail. So I thought what we would do is make ourselves a little Rust project. And see how Rust gives us an error if we do something wrong. So let's just make ourselves a variable. And now I was going to do something like x equals, I don't know, hello or something like that, and then get a compile error. But we haven't done type checking for this type of expression. In fact, this type of expression, I don't think even this type of statement doesn't even exist yet in our programming language. But we have just done type checking on while loops and saying that the condition in the while loop has to be a Boolean. So if we create something that's definitely not a Boolean, because x is some kind of number, and here it's being inferred to be an I32 because we're kind of not saying anything else, and then we're using it somewhere where we need a bool. So what we would like is to see an error like this that says expected bool found integer. Like this. And if we write a program like this right now in our language, we'll get nothing, I think. So let's try doing that, see what happens. So the way we're going to do that, we're in the type checking we're in our type checking file, and we're going to write some tests towards the end somewhere. Yeah, okay, so I think actually we want a very similar error to this, except it will be creating a variable instead of just passing in a literal thing here. So the code is going to look like exactly like what we did, like x equals 3, and then while x. And we're going to have to name this somehow. This test is going to be... I think really the fact that it's a while is kind of coincidental. The real point is variable with wrong type is an error, something like that. And then we should, if we got this right, the error message is going to look like it's going to be complaining about this line, and it's going to be complaining about just this x here. So I think these are just going to be spaces. So I think it's going to look something like this. And it's going to say found integer, which is the same as what it says here. Yeah, so with any luck, our error message is going to look really quite close to what Rust gives us. So let's run the tests. I should check I've committed. I surely have, but yeah, let's double check. Yeah. So the only change is this: we've added this test. Right. So when we run the test, our new test fails because why? It can't parse this because it didn't expect that closing curly bracket. But this was okay. I guess it's different when it's the second statement in this, which is really bad. That shouldn't happen. I guess the first thing for us to do is just check whether, if we put something in here, is it okay? Hold on. What's going on? Oh, I put it in the wrong place. All right, try again. Okay, so it's still not okay if there's stuff in the while loop. So something... Okay, so it looks like in this video we're going to be fixing the fact that while loops don't actually parse correctly if they're not the first thing in the thing. So let's try and investigate this a little bit. But I think we need to go into the parsing code for this because we called unwrap on an error value at line 956. 956 is where we parse something, and if 956 is actually correct, then the lexing was okay, but the parsing failed, which makes sense. That would say unexpected token, right? So that makes sense. So let us ignore this test because I don't think we're going to get that parsing in this video, and let's go take this bit of code, maybe we can simplify it, into our parser and write ourselves a test that parsing that works. So it's a bit concerning that we can break parsing just by having it as the second statement in a list. So let's say parsing a while loop after another statement, and then let's just check that that could be any statement. Maybe it's not right, but let's try. So I guess it's going to look a bit like this. Basically, it's going to be parse this thing, and then the output should be what was this? Yeah, this was a block. So this is just going to be a statement. That thing, yeah. Containing some stuff that we'll do in a minute, followed by a while with some stuff in it, and yeah, okay, so statements look like this. Very much like this. All right, so this is the first time we're suffering, by the way, for the change we made recently, where we, instead of saying what characters the leaf token contains, we just say where it is. So it goes from 0 to 1 in this. It's just basically the first character is the statement, or rather statement consists of essentially a leaf, like basically just a thing. In this case, the thing is number 3. Is that right? I think that's right. What else is there other than leaf? Not unit. Not any of these other things. It must be a leaf. Okay. I mean, this it will be fairly clear, although the error messages are not great that we've designed, or the way we've designed it. But it'll be fairly clear that if we did this wrong. So that was a statement. Then we have a while, and the condition expression should just be a I mean, I'm a bit confused why leaf tokens are, why we're not seeing like numbers or thing, like shouldn't there be, oh yeah, we are, there's an int, yeah, okay, it's fine. It's a leaf token that contains, in this case, a symbol. Okay, so I was missing the fact that we did say it was an int, and I was saying like, why are we just saying it's a leaf? But we are saying it's an int, so it's fine. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's characters 9 and 10. Where's that? From here. Or rather 9 to just before 10. And then a block, which is, what does that expect? A box of syntax tree, and this while loop is, there's nothing in it. So what's that? Oh, I think it's unit. I think that's how we represent that. Okay, so all of that was just like, what is the, when I've parsed this, what do I end up with? And this should be a box of that. Anytime we can hold a syntax tree inside a syntax tree, it needs to have that indirection. Okay, so now this test will fail if I've done it right. Yeah. So for some reason, when we're parsing a while loop without this, no, it still fails. Okay, I've got it totally wrong. It's not after another statement. It's parsing a while loop, which doesn't have an operation here. That's the problem. How interesting. So we could even have, like, say, 3 here. It's still no good. Okay, so the while loop is like, has hard coded. So we could just for the sake of like this being a valid statement, we could say something like this. We haven't done true and false yet though. So let's go back to just something like this. So it's not semantically valid, but it absolutely should parse as this is an expression. And how do you know when you've got the end of an expression when you're parsing a while loop? Is it that you hit a curly bracket? Or is it that, yeah, it can't be just like you've parsed something that would be valid, because you could definitely do something like, you know, X and Y, say, and then if you parse just the X, then that would be a valid expression, but we don't want to continue on. But it can't be just until I hit a curly bracket, because maybe a curly bracket could be part of a valid expression. Maybe. Maybe not. But I think that's what we'll do for now. So this is parsing a while loop with non-operation as condition. And I guess that means this test should go near our other while loop stuff. This isn't some kind of special case. It's just while loop stuff. So Okay, so here we are. Parsing a while followed by an expression is an error, right? No, it's just like you got to the end of your while, so you can have a statement after it. Yeah. So we should also be able to parse something where there is not an operation as the condition. So let's see that fail. Yep, it failed. So let's have a look at how we parse while loops. Here we are. To do this should also contain the code that lives inside the while loop. I mean, block lives inside the while loop. I think this to do is out of date unless it means something different from how I read it now. Maybe I'll figure that out sometime, but for the moment, get rid of that. So here is where we parse a while loop because we're in parser. We're in this thing called parse. Before we were in some test code that just allowed us to create a while loop. Okay, and here we've got a to do because the point is when we're parsing this thing or something like it, we carry on parsing until we hit an end marker, and the only end marker we're passing in by default is semicolon. So we need to say also a curly bracket will mean the end of your expression, an opening curly bracket. So that should be, I mean, I'm worried that that's not the right algorithm, but we can implement that algorithm reasonably well. So let's make ourselves another thing called end markers, which is a result of combining end markers with, now how do you stick things together? Concat doesn't seem to be, concat means concatenate all these things together, which is not what we want. We want to, do I have to use an iterator to join this on to something else? I'm not seeing. There's lots of things you can do. Like turn it into an iterator and then turn it back again. We could just copy it into a vec and then append something to the vec. Would that be better? No, I think so let's do .iter.chain and then I think it's iter colon once to say I want another end marker. So end markers is a slice of token kinds. We turn it into an iterator. We add one on, which will be a token kind. Brace open, and then we collect it back into a vec. So I guess we better say that this is a vec. And then we'll pass a reference to that into here. Okay, so iter once, well, maybe I just need to import iter. Can I just pass in a reference there? No. Oh, this should be into iter. Maybe, or maybe we need to actually copy this because we can't. So this should be a vec of token kind. So let's be explicit. And then that'll tell us you can't collect a vec of references to token kind into... Okay, so maybe we should make a copy and append something. What's the end of it? So end markers is a slice of token kinds. When I call into iter on it, surely it should return me an iterator of token kinds. But I guess then when you iterate through it, you get references to token kinds. Is that right? Okay, well, what if we just as 2vec, is it? 2vec it. That should work. I mean, we'll fix this in a minute if we don't like it, but now we can append something onto it using push. Like so. And now we've got a vec of token kind that we can pass in to self-experience. All right, so that at least compiles. We should explain this a little bit. Now, can we do better than that? Because potentially this push like allocates memory. Whereas if we used an iterator, it would, or something else, it could like measure and know what size vec to put it all in. We could do that ourselves manually, but that feels really painful. So what if we just got rid of those for a second? I mean, why does the expression take a slice anyway? It's not unreasonable. It's not unreasonable. I mean, it should take a set or something, but yeah, okay. So we start with a slice of token kind. We want to get an iterator of token kind. But when we just call into iter on it, the type of end markers is an iterator where the item is a reference to a token kind. Because I guess we can't. Okay, so we could then do, say, a cloned on it. And now we got a iterator. Oh, okay, so the problem was end markers, we can't like take ownership of the stuff inside end markers. So even when we into iter it, we take ownership of end markers, but not the stuff inside end markers. So we've still got references to those things. So now, okay, so now we've got an iterator of actual token kinds that we own because we cloned them all. So now we can chain on another iterator of length 1. That's what iter once gives us. And then we can make our token kind there. So now we've made an iterator. So we made an iterator of token kind by doing this cloned thing. Then we're chaining on another iterator, but that iterator only has one thing in it, which is just an opening brace. And now we collect, and it should work. But we need to say what we're collecting into, which is a vec. And it's a vec of token kind, so it can now be passed into end markers. All right, so that's better, I guess. I use this pattern quite a lot, where you chain and then just add one thing on. I almost feel like iter should have some kind of like push type thing, something that just says, just add one thing on for me. And I also feel like this is very verbose, isn't it? Like iterating and then cloning. But okay, never mind. Right, so a comment to explain this. Stop parsing the expression if we hit a opening brace. I guess that's enough. Should that be in quotes? Maybe, I don't know. All right, is that going to make our test pass just like that? Close. It looks to me like it's passing. I just got the test wrong somehow. So, oh well, I did the test completely wrong, right? Because I changed the test. So now, where are we? Look for whiles. Here we are. So that was the one that failed, right? Yeah. So previously I said there was like a statement before it, but that didn't matter. What mattered was the while loop, and the while loop was 0, 1, 2, 3, 4, 5, 6. So character 6, just character 6, in fact, like so. Okay, and it's getting closer. We said int here, but it should be. No, sorry, we said symbol. It should be an int because I changed my mind and just put a 3 in there. What else? Oh, and then it should be, it's a block containing nothing. So it shouldn't be a unit, it should be a block. And block takes in a set of statements, which is just going to be an empty vec. And a final expression, which is going to be a unit. So we need to make a box again because this is a syntax tree. And inside the box is just a unit. Okay, so when we run this, now it passes. Okay, so we've done some good work here. We have, well, let's skip to the end. So we've made ourselves a test which doesn't pass yet, but well, we should check that in a second. But yeah, we've made ourselves a test of what we'd like to work, which is that when you say x is 3 and you try and put it in a while loop, the type checking code fails, but the parsing code should be fine. And what we had at the beginning was that parsing this failed because of this thing. I really feel like maybe, is there some kind of expression which starts with a curly bracket, which contains an open curly bracket in it, but which is allowed in a while condition? Maybe Rust doesn't have any expressions which contain curly brackets? Well, a block statement contains a open curly bracket. Okay, let's not get distracted, but that is something to think about in future. Like in Rust, are you allowed? Oh, quickly try it. We could quickly try it, couldn't we? In Rust, are you allowed this, a block statement, which returns a Boolean, so it's kind of allowed as a while thing. Or let's just do, let's make it a valid block statement. There's a reason for having a block statement, which is that some other stuff happens here. Then we return true. Okay, that looks like Rust is happy. But what if it was like true and this thing? Oh dear, Rust is cleverer than us. Because look, it figured out, like, it's okay with that. It's okay with that. How does it know? How does it know? It must be that this thing that it parses here is not a valid expression, and therefore it's the body of a while or something. Okay, this example needs to go somewhere. And we need to do, which we'll never do, which is while expressions while condition. So I guess we can write this as a test name, parsing a while condition containing open brace. It's going to look like this. That is like the fact that that's valid Rust is interesting. The fact that Rust, it's just so much harder to parse Rust. So we won't do it. We won't do it. All right. So back to, I was explaining what we were doing in a really simple and effective way, wasn't I? Or what we did. Yeah. So first of all, we had a test that we wanted to get working, but it failed to parse. So we wrote ourselves another test, which just says, can I parse a while loop that has just say 3 as its condition? And the implementation of this is just that when we're parsing a while expression, previously we were just saying parse an expression, and if you hit a semicolon or something like that, then stop. But now we've said if you hit an open brace, stop. And that will do for like a lot of code will work. Like how many while conditions contain block statements? I mean, how does it, I guess, hang on, maybe this already works for us. Okay, now we have to try it. Now we have to try it. Sorry, this video was almost going to be this neat, tidy thing. So let's try it. Because I'm just wondering, because we're in the middle of an expression, like this, because that ampersand has told it, oh, I guess it's got to be something like this. Because it's hit this greater than or equals, it knows the expression, it knows it needs something else. So I'm hoping that means this will already just parse okay. Oh, it should be, the only operator we have at the moment is less than or equal. Okay, something panicked. I guess what it was trying to create an error message. Let's have a quick look. It panicked here saying, okay, I think this is because we don't support block expressions. I think it's because we don't support block expressions. So let's just say, what is this? Where are we? We're trying to create a leaf token from a token. And this is not a leaf token, I think. Is an opening brace a leaf token? Is an opening brace a leaf token? Well, if a semicolon's not a leaf token, I reckon an opening brace is not a leaf token either. All right, so I think I'm getting an idea of where this is coming from, but let's trace it back. Okay, so it's saying that 3 was an unexpected token. I guess because it started parsing this. No. Why? I guess it's because the way we're doing operations here is expecting a single thing to happen after. So let's double check that. If so, that's something we should fix fairly soon, because that is really means that we haven't really implemented parsing operations in a very good way. I guess, we're doing test-driven development and the one step at a time. But yeah, where's operations? Operation. Okay, so here's operation. And that's creating an operation. Let's try again. Parsing an operation. We've got a leaf or operation or mutation. And if it was an operation, we ask for the right operand. And the right operand is expecting it's not using end markers, so it's not like parsing an expression properly. It's just saying get me a token of type leaf token. So I think what it should be saying is get me any expression to go on the right hand side here. And then this will work. So I think what I'm saying is actually the test that we've written should pass if we were parsing operations properly. I think that's what I'm saying. We fixed our error handling a bit here, but hang on, I've learned a new shortcut in Vim. It's not working. Darn it. Why not? I was looking for like modified code that's been modified in Git. Maybe I don't have the Git plugin or something, which was square bracket in. I think I made that keyboard shortcut, so it's no use to you anyway. All right. Anyway, so yeah, I think actually this is working in the sense that we are in the middle of parsing an operation when we get here because we're partway through this operator. So I think this example would actually already work. Whether in Rust you can find yourself in a place where you're starting a block or some other reason for an opening curly brace, which is not mid-operation, but it's kind of potentially it's all over. And then it would be confusing to mix it up with this opening brace. But certainly this one, we can ignore. I think you just say something like this. And we're ignoring this because parsing right-hand side of operation is not yet done. But hold on, I just had a thought. We can have a block here. Like so, and have the right hand side of the operation be a thing, and that should already work. Oh no, that's ignored, so we don't know. Is that going to work? Well, it's definitely not going to come out as... Okay, now what happened here? Okay, something interesting here. All right, yeah. I think the left-hand side, I think maybe we're not parsing the left-hand side of an operation correctly either. So let's put this back. This is like an interesting corner case, but should work. Otherwise, so that means we don't need this to do anymore. Does it tell us why it was ignored? Yeah, look, it tells us why it was ignored, so that's kind of useful. Which means we got the syntax right for that. So what we were getting to was, we were looking at what we'd done. So we wrote ourselves an example that doesn't work yet, and we wrote ourselves a test of the thing we found that didn't parse. We fixed the parsing by, that's just a bit of error reporting, checking code. We fixed it by saying stop parsing if you hit an opening curly bracket. And the way this parsing works, this only actually stops if we hit opening curly bracket, and we've already got ourselves a valid expression. So when we're halfway into a valid expression, we're not actually executing this code. We're somewhere inside like a recursive call to expression, somewhere inside here. So we never hit that. So I think that's why it's okay. And this will actually work. Either way, I think we've made things better, because we can now parse while conditions that are not operations. There we go. All right. Hope you enjoyed. We will continue with this stuff, trying to get that bit of type checking of variables working, but I'm pretty sure it's going to take us quite a few videos. So back soon. See you next time.